of the problem that we think we have. Now, we consider that everything that we have talked to has led us to the point now where we have sampled properly, we have done the right kind of testing, and we have come to a hopefully valid conclusion that there's a microbial problem that requires action. It requires remediation. It requires this contamination control. Now, there are three most common microbial contamination control actions. They're classified as dewatering. You can see them on your screen, so I'm not surprising anyone. Dewatering, tank cleaning, and chemical treatment. So let's consider each of these. Now, we have, on the one hand, we say all the time, microbes need water to grow. We then have discussed that, well, they do need microbes, and they don't really need much water. Microbes don't really need much water at all to grow and thrive. I mean, depending on the kind of bulk fuel tank you have, let's say that you had water in it. So you said, okay, we got to get the water out because we want microbes. So you pump out the water, and you get a lot of water out. But let's say you leave 1/8 of an inch in there. Remember that, 2 or 3 millimeters. And depending on your size of your tank, that might be like 2 gallons. So we'll say you leave 2 gallons of water in there. Now, remember, we said that bottom water can have, each milliliter can have 100 million to 1 billion microbes per milliliter. So 2 gallons of water, that's like, let's do the math, that's like 7,500 milliliters. That basically means those 2 gallons of water, that 1/8 of an inch, is enough water to support 8.5 trillion microbes. So hence, it is really, really important to get as much of the bottom water out of the tank as possible, while also expecting that you are not going to get all of it. And the simple fact that bottom water has so much more concentrated microbial presence in it, that means we need to do more than just remove the water and, hope for the best. We need to do some other things if we hope to stay on top of this problem. Well, what kind of things? The need for additional steps. What are those additional steps? Well, tank cleaning. That was the second thing after dewatering. Now, the gold standard of tank cleaning is man entry, which is, I think, what that guy's doing. Let's see, is he doing that? No, he's actually not. But he's standing on top of the tank, so it looks cool. Man entry, gold standard of tank cleaning. That's where you get a guy dressed up in a hazmat suit. He actually goes into the tank and actually physically cleans the walls of the tank. Now, he doesn't do it with a toothbrush or anything. He uses spray, but he's able to get in there and actually, get everything out. That's the gold standard. But not many have the ability or the desire to really go that far. They don't really want to do that because it's expensive. So we work around that. We do the best we can with what we call extra tank cleaning or external tank cleaning. Basically, tank cleaning from the outside, where you've got a suction system and you're using stingers and vacuum hoses and things, and you're trying to suction out as much of the biofilm and as much of the water and stuff out of the tank as possible. But as good as you can try, as complete as you think your tank cleaning efforts are, just like with water, it is virtually impossible to get all or even most of the biofilm that's out of that tank, because while a lot of it is, in that plus or minus 15 degree zone, that's that bottom dead center that we talked about, that's really the limitation. That strip's really the limitation for how those stingers, or the typical tank cleaning stingers, can reach. It can't get all that other biomass out there. And one reason why tank cleaning is important in this context, too, is if you're going to use biocide, many biocides can only penetrate a certain way down or a certain point down into the biomass. If there's a lot of biofilm that's left, if you didn't get all of it, well, depending on how much you leave behind, it increases the chances that the biocide treatment that you're going to follow up with may not be as fully effective as you might want it to be. So you want to remove as much of the water as possible. That's dewatering. You want to remove as much of the biofilm formation as possible. That's tank cleaning. We know in both cases it's virtually impossible to get it all. And that means the third element of contamination control is so much more important, and that's chemical treatment. Now, in times past, we have talked about biocides, and we talked about the elements that make for a good biocide. And for Bell Performance has two biocide chemistry options because there are multiple different kinds of chemistries that you can use. Now, you've got Belicide, which is a thiocyanate chemistry. If we were describing it in broad terms, we would say it's got excellent broad spectrum action, which means it kills a lot of different microbes. And we would say it partitions well across the fuel-water interface. Basically means it can dissolve in the fuel, and then it can move into the water phase, and it can keep killing, and that's important. There's also Belicide ISO, which is our secondary biocide, which is, as of June 2018, is in process of being registered, and that is an isothiazolone chemistry. That's a chemistry that is probably the most widely used around the world, so it's got a lot of international registrations. It's broad spectrum, like the thiocyanate. It has a very low sulfur load, which makes it ideal for use in ultra-low sulfur diesel fuels that are not high turn. So we have two effective chemistries, but you need to use them properly. Biocides, biocides need time to work. And the period of time that you allow them to work, I've called it residency time, but in the technical term would be soak time. So you ask a fuel microbiologist, how long should my soak time be? And the microbiologist would say, well, optimally speaking, 24 to 48 hours. If you got a smaller tank, 12 hours could be optimal. But not all systems are the same. Not all systems have the same amount of microbial contamination. You could have a heavily infected system, right? Is that going to require the same soak time? Well, no. Intuitively, we know that we're going to have to change some things up. So if you have a heavily infected system, you may have to wait longer. And you've got the whole plugged filter thing. Because remember, it kills the microbes, but the microbes still have to go somewhere. So if you had a heavily infected system, not only would you have to give it adequate soak time, but you would plan on having plugged filters until the killed microbes and associated biofilm has been flushed from the system. Now, in the past, when talking about soak times for biocide, we've said 2 or 3 hours. So why are we now so significantly different? Well, there's a couple of ways we can answer this question. We could answer this question from the standpoint of couching it in terms of what the time capabilities are for a given partner, like a fuel service company, that how much time they can allot to waiting. I mean, there is that. But the biggest difference when you're talking about, if someone says basically, well, you said it only took 2 hours to kill. Now you're saying 24 hours. Why is there such a big difference? Well, the answer to that is it primarily comes from the fact that there's a difference between what happens in the real-world field applications and what happens when you put something in a laboratory under controlled conditions. In a lab setting where you control all the parameters, it's much easier to get fast results in a lab when you're talking about kill time. But in the real world, you have different constraints that play in. You have different constraints and factors that affect how you're adding the product. You've got variations in tank design, amounts of fuel that's in there, the ability to turn that fuel at given volumes and velocities for X periods of time. So categorically speaking, you would always know that in the real world, complete remediation takes a longer amount of time than it does under controlled conditions in a lab. Now, um, some caveats that we need to acknowledge before we can really consider that we've addressed this on a complete level. Caveat number one, not all tanks are the same. In the rush to simplify solutions, sometimes that can be a disservice to the customer. And that disservice really is implying that one size fits all, in the sense that no matter how heavily infected the tank is, no matter what design the tank is, one shot of biocide is going to kill everything every time. Now, I won't say that many times it doesn't happen, but there are certainly going to be cases where, again, because of certain factors, you're going to have to treat a tank a second time to ensure that the problem is wiped out. And a good fuel microbiologist will say, well, of course you will. You just can't predict with 100% certainty that this effect is going to happen 100% every single time. Life just does not work that way. Not all tanks are the same. Not all contamination levels are the same. That's a big thing. You may have to use more biocide in a heavily contaminated system. Even though our biocides, even though thiocyanate and isothiazone chemistries are broad spectrum, you also have to recognize that not all microbes respond exactly the same to them, too. This is why, and we're tying this all together. This is why it's important to do things like condition monitoring. If you're not doing condition monitoring, if you don't have a tool like ATP testing to enable you to do that, then many times you are only guessing at whether you have solved the problem. So, what's the biggest thing that affects whether you're going to have multiple biocide applications? Biggest thing is the level of contamination. There are many tanks that may require 2 or even 3 applications. 3 is kind of rare, but it happens. How would you know? How would you know if you have to reapply biocide? Only through ATP testing, only through condition monitoring after you apply the biocide. Only then could you actually determine if the microbial levels had actually been reduced to your desired level. And then, last thing also is, having said that, this is also where pairing the biocide with a biomass dispersant like tank treatment, SDF, this is where that becomes useful because, microbes like biomass, sometimes it shields them from the biocide. Tank treatment SDF helps to disperse the biomass, breaks this stuff up, and it significantly reduces the possibility of needing to do a retreat, do a retreat 2 or 3 times, something like that. So that is why it is useful many times to consider pairing biocide with a dispersant like that. So we are coming up towards the end of this thing. We have covered an awful lot of things over the course of this training, now running up on almost 2.5 hours, so we're going to get out of here before the 2.5-hour mark. Hopefully, besides some useful tidbits about fuel microbiology and important aspects of it that inform what we do with Bell FTS, some of the things you should be coming away with, you should be leaving with this. So let me rephrase that. You should come away at the end of this with a sense that, number one, when you're talking about microbes in fuel, quote unquote, that whole issue is a lot more complicated than it might seem at first. We should be able to easily recognize that microbial contamination control in tanks is a never-ending process because microbes are all around us. That requires us to pay attention, both to prevent microbial problems and then, and to recognize them and to fix them when we find them. In other words, a one-size-fits-all approach is not going to cut it anymore. And our goal, Bell Performance's goal with the Bell Fuel and Tank Services program, our goal is to make this whole process, this condition monitoring, this contamination control, all that, make that entire process as cost effective and as easy for our customers as possible. And that, my friends, brings us to the end of our training on fuel microbiology, everything you were everything you ever wanted to know but were afraid to ask. If you have any questions, you know where to find me. I'm Eric Bjornstad with Bell Performance. Thanks for joining me. It's been a long training, but we have covered a lot. If you have any questions, call me at the office. Email me here at Bell Performance. Be happy to try to help you whatever way I can. And with that, let's sign off. I'm Eric with Bell Performance. Thanks for joining me, and we'll see you next time.